Welcome to the next section, Automated Acceptance Testing. In this section, we will first introduce you to the concept of acceptance testing process. Then we will explain the idea of the artifact repository and create the Docker registry on Docker Hub. Moving on, we will introduce and explore Docker Compose, and we will use this Docker Compose in the acceptance testing process. Finally, we will be writing acceptance tests with users. Now, let's move on with the first video of this section, Docker Registry. In this video, we're going to learn about acceptance test, and then install Docker Registry and finally use it. Acceptance testing is a test performed to determine if business requirements or contracts are met. It involves black box testing against a complete system from a user perspective, and its positive result should imply the acceptance of the software delivery. Sometimes also called UAT, user acceptance testing, end user testing, or beta testing, it is a phase of development process where software meets the real-world audience. Many projects rely on manual steps performed by QAs or users to verify the functional and non-functional requirements, but still, it's way more reasonable to run them as programmed, repeatable operations. Automated acceptance tests, however, can be considered difficult due to their specifics: user-facing, dependencies integration, environment identity, application identity, relevance and consequences. Docker Registry is a storage for Docker images. To be precise, it is a stateless server application that allows the images to be published, pushed, and later retrieved, pulled when needed. We have already seen an example of the registry while running the official Docker images, such as Jenkins. We pull the images from Docker Hub, which is an official cloud-based Docker registry. Having a separate server to store, load, and search software packages is a more general concept called the software repository, or, even more general, the artifact repository. Let's look closer at this idea. Artifact repository. While the source control management stores the source code, the artifact repository is dedicated for storing software binary artifacts, for example, compiled libraries or components, later used to build a complete application. We need to store binaries on a separate server using a separate tool due to file size, versions, revision mapping, packages, access control, clients, and use cases. The artifact repository plays a special role in the continuous delivery process because it guarantees that the same binary is used throughout all the pipeline steps. Let's look at the figure presenting it working. The developer pushes a change to the source code repository, which triggers the pipeline build. As the last step of the commit stage, a binary is created and stored in the artifact repository. Afterward, during all other stages of the delivery process, the same binary is pulled and used. Depending on the program language and technologies, the binary formats can differ. Install a Docker registry. First, we need to install a Docker registry. There are a number of options available, but two of them are more common than others: cloud-based Docker registry and your own private Docker registry. Let's dig into them. Docker Hub is a cloud-based service that provides Docker registry and other features such as building images. Docker Hub is cloud-hosted, so it does not really need any installation process. Docker Hub may not always be acceptable. It is not free for enterprises and, what's more important, a lot of companies have policies not to store their software outside of their own network. In this case, the only option is to install a private Docker registry. The Docker registry installation process is quick and simple, however. Making it secure and available in public requires setting up access restriction and the domain certificate. We will now install Docker Registry application. Docker Registry is available as a Docker image. To start this, we run the command. The command starts the registry and makes it accessible via port 5000. The registry container is started from the registry image, version 2. The restart equals always option contains the container to automatically restart whenever it's down. Next, we will be adding a domain certificate. If the registry is run on localhost, then everything works fine and no other installation steps are required. However, in most cases, we want to have a dedicated server for the registry so that the images are widely available. In that case, Docker requires securing the registry with SSL/TLS. The process is very similar to the public web server configuration, and similarly, it's highly recommended having the certificate signed by CA. If obtaining the CA signed certificate is not an option, then we can self-sign a certificate or use the insecure registry flag. You can read about creating and using self-signed certificates at. Having the certificates either signed by CA or self-signed, we can move domain.crt and domain.key to the certs directory and start the registry. So we first clear everything and enter this code. So we have moved the domain.crt and domain.key to the certs directory and started registry. Using the insecure registry flag is not recommended since it provides no security at all. Unless we use the registry inside the well-secured private network, we should configure the authentication. The simplest way to do this is to create a user with the password using the htpassword tool from the registry image. So first we create a directory named auth and run this command. Here we enter username as root and password as pass123. The command runs the htpassword tool to create the auth passwords file with one user inside. Then we run the registry so that one user authorized to access it using this command. The command, in addition to setting the certificates, creates an access restriction limited to the users specified in the auth password file. Docker Hub and Private Registry are not the only possibilities when it comes to Docker-based artifact repositories. The other options are general-purpose repositories, cloud-based registries, and custom registries. Using Docker Registry, when registry is configured, we can show how to work it with 3 steps. The first step is building an image. Let's use the example from section 2, introducing Docker, and build an image with Ubuntu and the Python interpreter installed. In the new directory, we create a Docker file, and here we paste the Docker file command and save it. Now we build the image using the build command. As you can see, the image has been built with Python. Next step is to push the image. In order to push the created image, we need to tag it accordingly to the naming convention. This is our name convention. The registry address can be username in case of Docker Hub, or else it could be a domain name or an IP address with port for a private registry. We will now tag the image to use Docker Hub using tag command. If the repository has access restriction configured, we need to authorize it first, so we authorize it. It's possible to use Docker logging command without parameters, and Docker would ask interactively for the username and password. Now we can store the image in the registry using push command. So we remove this command and add this command. As you can see, the image is being stored. So the repository has access restrictions configured. We need to authorize it for pushing our image. Note, there is no need to specify the registry address because Docker uses the naming convention to resolve it. The last step is to pull the image. To demonstrate how the registry works, we can remove the image locally and retrieve it from the registry using docker rmi command. We can see that the image has been removed using docker images command. Then, let's retrieve the images back from the registry using pull command. We can confirm the image is back with the docker images command. When we have the registry configured and understand how it works, We can see how to use it inside the continuous delivery pipeline and build the acceptance testing stage. With this, we end our first video. We successfully used Docker Registry.